Good morning, students. So, today's topic is electric field intensity due to infinitely straight line charge. Here we have two methods for this. One is by Gauss Theorem and this one is without using the Gauss Theorem. This also the NCERT example also in exercise. So here we start our this derivation electric field intensity due to line charge by Coulomb's law. Here we have a line charge. Let from its point O at a distance x there is a point P at which we have to calculate the net electric field intensity. From this point O at a distance L there is a point M, and here there is a small element, line element dl. So due to this line element dl at point P, the intensity be dE. Due to this dl element at point P, the intensity on the same line of the action, that is dE. Similarly, we can take another side, the small element dl, same in the same manner, intensity be dE. Let this angle here, the angle is theta, so this angle also will be theta. Resolving this electric field intensity vector dE on the basis of this theta, so dE cos theta and dE sin theta. Here dE sin theta will cancel out, equal and opposite, so the net electric field will be the summation of this dE cos component. So net electric field E will be integration or summation of cos component of dE, it means dE cos theta. So by Coulomb's law, E is equal to 1 upon 4 pi epsilon naught Q upon R square. Here Q is dQ because small element dl, small charge dQ, and R is the line joining to the point of observation to the charge. Here the line joining distance is root L square plus x square. So here R is root L square plus x square whole square here into cos theta. Clear? Now we know the linear charge density lambda is equal to dq upon dl, the charge on per unit of length. So from here dq is equal to lambda dl. So in place of dq here we can put lambda into dl. So placing same E is equal to 1 upon 4 pi epsilon naught in place of dq lambda dl L square plus x square into cos theta. Let this one equation first. Okay. Now in triangle MOP, in this triangle MOP, we take a triangle POM tan theta. Tan theta equal to perpendicular upon base, so L upon x. So from here L equal to x tan theta. Now differentiating with respect to theta, so d upon d theta of this L is equal to x constant, differentiation of tan theta is sec square theta. Is sec square theta. So dl is equal to x sec square theta d theta. Now putting this value dl from equation second into the first. So in place of this dl we can put this x sec square theta d theta, and in place of L we can put x tan theta. So L equal to x tan theta and the value of dl, putting the values in equation first. Okay. So E is equal to 1 upon 4 pi epsilon naught lambda dl. So in place of dl this value x sec square theta d theta, and in place of here L we can put x tan theta. So L square means x square tan square theta plus x square. taking common x square from here, 1 plus tan square theta. Yes, 1 plus tan square theta is equal to sec square theta, its identity. So 1 plus tan square theta, sec square theta cancel out, 1 power of x can be cancelled here. So finally we have E equal to 1 upon 4 pi epsilon naught lambda upon x into cos theta. So this the solved value here, E is equal to 1 upon 4 pi epsilon naught lambda upon x into cos theta d theta. So here taking the constant out from this integration sign, E is equal to 1 upon 4 pi epsilon naught lambda upon x integration cos theta d theta. Now in order to find the infinite line, we have to integrate it from minus pi by 2 to plus pi by 2. This I will explain in my next lecture. So minus pi by 2 to plus pi by 2 cos theta d theta. Integration of cos theta sin theta, applying the limit minus pi by 2 to plus pi by 2. Now putting the upper limit and the lower limit, sin minus theta equal to minus sin theta. So minus this minus become plus 2. So this 2 cancel to the 1 upon 4 pi epsilon naught by 2. So E is equal to 1 upon 2 pi epsilon naught lambda upon x. E is equal to 1 upon 2 pi epsilon naught lambda upon x. This is the electric field intensity due to the infinite long line charge. Thank you.